Hello everyone and welcome back to another video. Today we are talking about the quantum internet and one of the major, let's say, infrastructure providers in this field, which is called Qubitrium. And if you are interested in learning more about the quantum internet, what it is, what it might become, and also in how this is actually being realized today and what Qubitrium is doing that might also be different from others in the market, then today's video is exactly right for you. So as always, make sure to get yourself something to drink so you stay hydrated throughout the video. And with that, let's dive right into Qubitrium. So here we are on their website. We see this very cool animation here in the background. And it says, from fiber to constellation, we build the quantum internet. Quantum technology is transforming the world and we are at the forefront. We deliver advanced solutions in quantum cryptography, communication and sensing, along with services that bring these innovations directly to industry. Shaping the future, so we are shaping the quantum internet of the future with our terrestrial and space modules. Then we see here a couple of images of the different products that they have, and we will learn more about that in a moment, as well as a little animation of the satellite. And then here we are already in the products section down here. And here we see the different, let's say, components in the carousel. So it starts with the qubit core, which is for space applications, so that can go on a satellite. This is the fully integrated product. We see the CubeSat SPD, so single photon detector, right? It can also go into the space. This one here is for terrestrial and space entangled photon source, which you need to create these photons for the quantum internet. We'll talk about that in a minute. High voltage amplifier, also important thing that you actually need for the integration. The indium gallium arsenide detector, so this is for the photon detection. So after you generate the photons, you need a low noise detector to actually detect those. Laser current driver, also clear. You need to basically create the photons. You need a current source for that. QKD demo setup, so quantum key distribution demo to demonstrate how quantum key distribution works. A receiving module, and then I think the next one is superconducting. Yeah, that's only for terrestrial applications. Single photon detector SPD with superconducting. Well, that doesn't look superconducting, sorry. Just a single photon detector for terrestrial application, not superconducting one. And then we have the time tagger here, which I think plays a role both in space and terrestrial for time tagging of these communication signals, right? So you also always need to have a clock related to this. Then there's a link here to start a partnership and the news section down here. I'm recording this in May of 2026 and the latest news here is from April of 2026. A quantum payload reaches orbit. Commercial quantum communication is on the horizon. So that's the satellite animation we saw before. And then here's the one from end of last year, end of 2025. Qubitrium secured 2.25 million euros in seed plus funding. Furthermore, you find scientific reports down here, partners which they are collaborating with. I'm not going to go through all of them, but I think what is very well known is NATO probably. Aselsan is also very big. Quantum Delta Netherlands is also known in this context. Turksat as a Turkish satellite provider as well, and there are others in there as well. And then as per usual, we find the footer of the website with all the relevant links to news, contact them, and all the social media. Now, let's quickly look at the products. We have seen them before, but just to go through them once again. Here they are ordered by space. So this is what goes into the satellites, as well as the terrestrial one. I want to, this one I think we haven't seen before, rack mount QKD system. But I mean, that's something that you can also see with other suppliers. I want to go in this qubit core for once, just to show what one of these products look like. And this is also the one that goes into the satellite, which I think makes it interesting. So the qubit core is a CubeSat satellite compatible entanglement distribution payload designed for space-based quantum communication missions. The payload integrates a miniaturized entangled photon source, 2 optical receiving modules, and an onboard time-taking unit in a compact architecture. Each receiving module includes a dedicated optical design and 4 single photon detectors for coincidence and correlation measurements. Entanglement-based BBM92 quantum key distribution protocol is fully implemented and optimized for space operation. Qubit Core is designed as a self-contained payload suitable for CubeSat platforms, enabling secure key distribution experiments and demonstrations in orbit. So this is basically the first step into bringing quantum internet or quantum communication into the orbit. This is something that has been demonstrated also by other companies in the space already, and is part of, let's say, a bigger networking architecture that also Qubitrium is following, which is partially based on the ground. So having these networks that are based on the ground for, let's say, smaller distances, usually up to 100 kilometers, when you have, for example, compute nodes that are, or we will have these receiving stations that are communicating with the space. Then it goes down, and from there on, you can basically use optical fibers, for example, to create quantum secured communication channels to then communicate between the receiver, the ground receiver station, and the end user, for example, I don't know, some national agency. So with that setup, you can then basically have on the ground to the receiving station. From there you go up to space, and from there you can go basically around the globe wherever you need to go if you have enough of those satellites, and that's how you set up this communication, which is based on single photons, so based on quantum particles, which secures it against, for example, eavesdropping by the non-cloning theorem and the correlation measurements in quantum mechanics. And for that, you need these single photon sources, single photon detectors, because you're really looking at single units of light, these single photons, as well as these entangled photon sources, which create 2 photons that have, let's say, for example, opposite spin polarizations. That have opposite spin polarizations, and therefore you can basically use this entanglement to actually create this quantum key distribution, or to make it safe from eavesdropping, to distribute a key that you can use to encrypt your actual message and make that key safe from eavesdropping. Okay, so far so good. What is interesting, I think, also about the company is that, I don't know if that's somewhere over here. Let's see if we can find it maybe here. So this is the team. We see the 2 co-founders, I guess. Here. I think it's under contact. What is interesting is the company is, let's say, in a way European. So there's an office in the Netherlands and an office in Turkey. So 2 places, and I guess the 2 co-founders are basically distributed across these 2 places. And then let's also, I thought there was something else I wanted to show you. Let's also quickly take a look at the company itself, right? So about the company, we are enabling the future of secure global communication with scalable quantum modules for space and terrestrial networks. The founding story, so Dr. Kadir Durak graduated from the physics department at Middle East Technical University, METU, in 2009 and began his PhD in atomic and molecular physics at the University of Singapore the same year. After completing his PhD in 2015, he spent 2 years as a team leader in a research group at the Quantum Technology Center, working on satellite-based quantum communication from space to Earth. Dr. Durak, whose research focuses on quantum cryptography, photonics, quantum electrodynamics, and quantum information, returned to Zhejiang University as a faculty member in 2017, continuing his role in the electrical and electronics department. Dr. Durak also founded Qubitrium in 2020, a startup serving in the fields of quantum cryptography, communication, and quantum sensing. What we do, so founded to develop advanced quantum technologies on the cusp of the second quantum revolution, which is the quantum revolution that we are in right now, which is about sensing, communication, and quantum computing. Our company offers solutions to problems in the fields of quantum communication and quantum sensing. These are the quantum internet related components that we've seen before. And in order to create these quantum communication channels, you need to have quantum sensors, as in single photon detectors, entangled photon sources, and these are all, like on the hardware side, being created by Qubitrium. Back to the text. So while providing services to develop and manufacture advanced quantum products, we also prepare training programs and quantum technologies for industrial organizations. We are developing the building blocks of quantum internet for use in space and on Earth, such as entangled photon sources, single photon detectors, and time-stamping modules. At the same time, we are conducting advanced R&D work on quantum memories, diamond defect-based sensors, magnometers, and quantum position, navigation, and timing solutions with strategic partners from Europe, the US, and Turkey. And then, we have the news section down here again, as mentioned, latest news from April 2026, while I'm recording in May of 2026. Good. I think that's already it for today's video. Definitely, from my point of view, one of the companies to kind of keep on the track, especially combining, let's say, the quantum sensing side of things and the quantum internet side of things. The quantum internet is something, or quantum communication is something that we see is coming. There's a lot of good reasons to look into that already today. One of them being the idea of today's cryptography being cracked by quantum computers in the future. So harvest now, decrypt later. We can already, let's say, copy data from today's encrypted information exchange from asymmetrically or symmetrically encrypted algorithms, and then potentially use quantum computers in the future to also crack these messages that are being recorded today. The only way to make sure that nobody has been eavesdropping in there and has been copying this information is to have a communication channel that is safe against eavesdropping, and this is where quantum communication comes in. This is one of the values that it basically brings. You're using quantum mechanics to detect if somebody's listening into your encrypted communication, and thereby you can prevent that there's eavesdropping happening in your communication channel. That's the description of today's video. I hope you found it interesting. If so, make sure to subscribe to this channel to not miss out on the next one. I'm looking forward to see you there. Until then, bye bye.